Hi everyone, this is an example getting into using area in a real world application, but it's also got some arc length in it. I really like this one. It's a pretty cool one, a little bit tricky, so you can see where you can have some pitfalls. So this is about a windshield wiper and how far different points on the wiper move. In fact, I'm just going to do one for the purposes of this example, and how much area it clears. So you've got the picture here. I did make a Desmos animation just because basically I'm totally geeking out on Desmos right now and I love it. So if you want to check it out, you can follow the link. Let's see if I have it open. I'm so excited about being able to make all these things happen. So this is what we've got going on. We've got the wiper moving, and the first part of this problem is interested in that farthest point on the end of the windshield wiper, the one that moves the farthest, and exactly how far is that moving. So back into here, we're talking about this arc right here. And we know we have the formula S equals R theta. We're told that the windshield wiper is 16 inches long. And then we're told that the arm that it is attached to is 18 inches long. And it's attached right at the midpoint of the wiper blade. So let's see, if this is 8 inches right here, then this right here has to be 10 inches. So there's a little bit of trickiness even with just figuring out what the radius of the different parts of this are. So this inside swipe has a radius of 10 inches, and that outer swipe looks like it has a radius of 26 inches. Okay, so this is going to become a 26 inches. And then we're given that it rotates through 100 degrees. So this whole thing right here is 100 degrees. But we know that if we're going to use the arc length formula, we've got to convert that. So theta is 100 degrees, but we're going to multiply by pi over 180 because we don't want those degrees in our units, right? If we multiply right now by 100 degrees, your big clue that that's not good is that your units become degree inches or inches times degrees, however you want to say that. They become nonsense. So I can cancel out my degrees, which is excellent. I can knock out a 0, and then 10 over 18, I can cancel 2 out of that and make it 5/9. So I get 5/9 pi, or 5 pi over 9. And that will give me the distance that that far point is moving. 26, oh, I have no idea what that is. Ooh, so here, got my calculator. 26 times 5 over 9 times 5 pi. 26 times 5 pi over 9. Hopefully I know how to use this calculator. What is that giving me? Hold on, I don't think I believe it. 26 times 5, I don't believe it. Okay, hold on. Okay, so on my calculator, these ones are always a pain. We want 25 times 5 times pi. 25 times 5 times pi. Is that really right? Hold on. 26 times 5 times pi. Okay, so let's see if I can get this right on the scientific calculator. 26 times 5 times pi. 480 divided by 9 is about 45.4 inches. So let's make that approximate. Okay, so the outer edge of the wiper is traveling roughly 45 inches in one swipe. This next part is kind of looking ahead towards part 3 of this section, where we talk about the speed of something moving along some sort of arc. So here, if the blade makes 2 swipes per second, how fast is the tip of the blade moving? So we can figure out how far it's moving. 2 swipes is going to be 2 times our 45.4 inches, so about 90.8 inches, and then it does that in 2 seconds. Oh, so actually I could have just done this, and it should get us right back to that 45.4 inches per second. Okay, Last part gets into the area. What is the area cleared by, what area is cleared by one swipe? So back up on my picture, I have all sorts of stuff written here, but I want to know how much is actually cleared. So I think the big pitfall here is realizing that you're missing that little segment down at the bottom with the 10-inch radius. And the question is, how do we then force the arc length formula to give us the right answer? And a lot of people, let me switch colors, are tempted to say, okay, well, let's just use this 16-inch radius down here, but that's not actually quite right, because what happens is if you just use a 16-inch radius and you sweep it through that same angle, it doesn't give you as big of an area. It's not the same as that whole big circular section minus the little one down there, which is what in fact we want to do. So to get the area of the swipe, we're first going to figure out the area of this entire thing, including that little section you missed down at the bottom. So that has a radius of 26 inches. So area is 1/2 of the radius times your angle, 5 pi over 9. And then we just have to subtract off that little inner piece. So 1/2, the radius of that this little inner piece right here is what we're subtracting out. The radius is 10 inches, and it's got the exact same angle, 5 pi over 9. So we're ending up with 20, I don't want to think as hard as 26 squared, so let's clear 26 times 26, 676, and we'll even be really lazy, over 2. So we have 338 times 5 pi over 9 minus 10 squared is 100, half of that is 50 times 5 pi over 9. Which you could just go plug that into a calculator. I think this is a real-world application. A decimal answer is going to be great here. We don't need the exactness. What we need is a useful answer that we can make sense of. You can also notice that these are like terms. If we have 338 5 pi over 9s and we subtract 50 5 pi over 9s, we're going to get, I don't know what we're going to get, 23088. Yep, I think that is right, times 5 pi over 9. And that I am going to go ahead and give to my calculator. So 288 times 5 times pi divided by 9. 502 point, oh, hold on, I closed it too fast. 502.7 roughly. About 502.7 square inches for that one. So they can get a little bit tricky, hopefully nothing that we feel like we can't manage, but do just pay attention in these problems and let me know if you have any questions. Thanks for watching.